Okay, so with that being said, I've started recording the meeting. Um, please go ahead. Erica, please go ahead. Your hand is up.
I can see the screen.
Someone else to break the tie? Anyone else that can see the screen? Anyone else that can see the screen to break the tie? Msonda, Lisi, can you see the screen? Okay, Msonda can see the screen. Right. Looks like on your end. So I assume you use an iPhone, don't you? You do use an iPhone? I see. So I would suggest if you were to succeed in these meetings, I assume you have a laptop as well. Maybe just be using the laptop, or the best is using someone who has Android. There are just these crazy features with you guys to do with iPhone, especially iPhone 10 plus, 10 plus, 10 Pro, 11. There are just these crazy features that most of the times will buy you from enjoying uh, certain services. So I would suggest that. Right. We hope she comes back. So like we were saying, you need this skill. Okay, it will take you far. So introduction to database. So before basically anything, I just want to take this opportunity to say to you, last year I prepared very nice notes for immediate seniors and made some PDF here and there. But these guys I was trying to ask, they're not responding as much. And the book I used to prepare that is in Lusaka, and I'm outside Lusaka. So all these tantrums, right? So the database. What's the background? The background is when you go in offices. Yeah, when you went in offices maybe 2 years back, even now, you go in the library, for example, we still have a lot of files in shelves, okay, and we do have a lot of shelves, a lot of shelves full of books. So there are a lot of disadvantage to that. One of the disadvantage is if the library catches fire, what would happen? Basically, all those books, we can't afford to rescue all of them. Okay, so what does that supposed to mean? When a book is lost, the impact is felt. When a book is burnt, the impact is felt. What's the impact? Number one, it incurs the cost. Okay, if a book was costing maybe 5 years ago 300, now that book can cost even 1,000. Now imagine replacing all those books. You have these files. Um, there there are worms. Okay, there are worms that can eat up these books. When these pages are eaten, they can't be replaced. So that another disadvantage is, as you buy lots of these books, it consumes or takes up a lot of space. Just like in business, you assume the space was okay, not until your business keeps on growing, then the space will keep on reducing because you are having a lot of orders. So what is going to happen? You need to change the space for business. Okay, and when people got used to finding you there, now you need to give a different address, which is quite difficult. And again, you'd find that you are keeping the same data repeatedly. Let's, for example, you're running a business and you have 3 departments: marketing, sales, and finance. Okay, like what happens in school, for example. That's a best example. In schools, in secondary schools, you have accounts office, you have deputies heads office, you have heads office, you have mathematics department, you have physics department, and all that. So you would find that a single pupil is appearing, the same pupil is appearing in different departments. Okay, so these have your details, these have your details, these have your details. So how is that a disadvantage? In as much as it is an advantage, because if your name goes missing in one department, you can find it easily in another, but it's a disadvantage if your information is updated in one department. It requires all other departments to update this information, otherwise there will be a mismatch. Let's say in this department you are still appearing as grade 11, but in the other department you are appearing as grade 12. So all these departments need to update grade 12, grade 12, grade 12, grade 12, grade 12, and so on and so forth, which is a waste of time. Now, the database, these guys say, okay, we can store all this information in form of software, online storage. We just design a file system which works on internet, so that every department which has computers can just go to the list and get your name. So if your name or details are updated, they're just updated once, right? And we reduce paperwork. We just do that once. So that is basically the background of the database. So because of this storage of the same information in different locations, which brings about consumption a lot of space, which brings about inconsistence, which brings about worms eating eating that, risk of fire, risk of being thefty, and also someone can just go and make adjustment. Okay, I'm in the office with you. Okay, you came to visit me in an office, then I'm pressed, for example. Okay, um, the officer go to ease themselves. someone can remain and take advantage of that opportunity because there is no code. Okay, they will just go in the file. Okay, this is my name, and someone got, for example, 60. They just modify it becomes 80, which is its advantage. Okay, so that is basically the background to that. Okay, so welcome to CSC 2702, Introduction to Databases. Okay, so what is the database? So database are important components of life in just modern society. Okay, because there are a lot of activities that you guys have received. I've received deliveries before, and these deliveries you need to sign somewhere to confirm that this is delivered. Some people don't give you where to sign. You just confirm to say, okay, you have received. So the person who has just delivered confirm with you that they have delivered digitally. So once they confirm digitally, that confirmation is automatically updated where they are coming from. That is one use. Okay, so database systems are important component of life in modern society. Why? Because most of us come across or encounter several activities every day that involve some interaction with a database. Okay. Let me confirm with are we in the meeting? Kindly give me a thumbs up. Are we in the meeting? Okay, I'm Sunday. Okay, thank you. Thank you for that. So what are the examples? Examples are just the ones that I've given. For example, getting a delivery, you have to sign somewhere, and so on and so forth. So traditional applications, we interact with numbers, texts, and so on and so forth. Okay, so in recent applications of database, basically we are just giving the background, we haven't yet started. So where in recent, okay, traditionally we were just interacting with numbers and texts, but nowadays we do have what we call multimedia. Okay, you guys, I believe, have been to the multimedia complex. Okay, how do you think they store those information? Is through the database. Geographical Information System, GIS. Okay, basically this is in the same category with the GPS. Okay, Geographic Positioning System. Geographic Positioning System is basically is just a system which identifies where you are. But the GIS just gives the information, like these guys who move, like Delhi guys, Yango, use what we are calling GIS. Okay, so it gives the information, the direction, just about the geography where you are. Warehouse, if I told you guys I have learned commerce before. Warehouse is basically where just a storage area, and you need to keep data about that. Okay, all up. We'll look at this at a later stage. Real-time or active database. We'll look at this at a later stage. Data set or query technique. We'll look at this at a later stage in just a moment. So we come, we start now coming here. What is the database? Okay. So the good way of looking at the database is we have seen and we have heard people that would come to you to say, okay, I'm doing a research, and the research I'm doing, we share a link with you, just open it and start clicking this, that, until you finish, and so on. So you can't conduct a research on two different topics. These topics must be related, okay? Or the data that you want to collect must be related to the topics. So you want to get data. That's the first thing. This data which you want to get, you want to get data, or you want to collect this data. This data you want to collect must be related. Not if it's about people, must be about people. If it's about employee, must be about employee. If it's about animals, environment, and alike. So that collection, a collection of a related data, is what we are calling the database. Okay. Basically, we'll look at more formal definition. But for now, that is fine. What is data? Data is just a fact, raw facts that will give you information at a later stage. That's the data. Okay. What are the examples? For example, names, telephone numbers, addresses of people. Basically, is a collection of related data. Okay. So how is this the collection of related data? So there are people here. First of all, there are people here. These people do have addresses. Okay, you want to find out about this person. One thing that you would want to find out about this person is the address. Okay, another thing is the phone number. Another thing is the name. Another thing, and so on and so forth. Welcome back, Erica. So we've just started. Database is just a collection of related data, and this is an example of collection of related data. So there's a person, the name is related to this person, phone number is related to this person, address is related to this person, workplace is related to this person, okay, and so on and so forth. Okay, so there are terms that you need to be familiar with about the database. This is the collection of related data, remember. Okay, now how are you going to collect that related data? Where? When? This is what we want to talk about. So you need to have the source. Okay, you need to have a source from which you are going to get that data. So usually represent some aspect of real world. Okay, then this data must be coherent. Okay, coherent means this data must not be random. There must be order. in which you are collecting this data. Okay. From which source? That's why when you have an assignment, for example, you're required to cite books, of which a lot of times we don't. We just get those and put them there. So what we are saying, there must be logically coherent. Means must not be random. Okay, there must be order in which you are doing that. Know that that data can change, because in as much you are collecting this data, this person can tell you this person can tell you this, and so on. You need to have a plan. Okay, you need to have a plan there. So database is planned. So a database is designed, built, and populated with data for a specific purpose. So that's what we are calling a plan. You can't just collect you can't just collect data for no reason. You need to have a reason. What is it you're collecting that data for? Very, very important. Who are you collecting that data for? So it has an intended group of users and planned for usage. Okay, moving on. Database management system, DBMS. Data must be planned. You need to have a plan for which you are collecting that data. You need to have what is the reason for collecting that data? Who are going to be users for that data? What is it going to be used for? That's what we are saying. For now, we are just looking at basically the introduction. We will look at this from practical point of view. Database management system, code DBMS. Okay, so database DB, then MS. Basically, this is just a software. Okay, we are going to look at because in this course we are going to be using MySQL, which is nice, and for reasons we are going to mention later. So we are going to look at MySQL. Database management system is just a software, okay, that makes you as a user to create and maintain database. Database is the collection of related data. So when you collect this related data, how are you going to store that data? Where are you going to store that data? So we are going to use a certain platform. For example, you know a word, you know Excel. For example, you've seen a word before, you've used it. You've seen Excel before, you've used it. Even the database, there's something looks like that. But this Word or Excel doesn't just work on its own. There's a software which controls how that Excel is working, which makes it possible for you to type in those letters and numbers. So even in this case, in this course, database management system is just a software that makes you to create database. After you create database, then you maintain that database. What is enabling you to do that is what we are calling database management system. Is that good? Give me a thumbs up. Okay, this is good. Sonda is good. Erica, I don't know whether you're getting me or not. Oh no. Really sorry. Okay. Again, it's not a good idea in as much as we are going to send the link to the recorded session. Attending to this is very important. Okay. So that is what we are saying. So this software, okay, does the following. Okay, it defines, it constructs, it manipulates, it shares. We'll talk about that in a moment. I can't see your screen and you're breaking. No. Okay, so it does a number of things. It protects and it maintains. Okay, so this software has 6 functionalities. Okay, number one, it defines. What is to define? To define means to specify data type. Okay, we're going to look at this in a practical way, but I want you to also get theory so that you get to see or you get to see what we are basically trying to talk about at a later stage. So to define the database means to specify the data type. Let's say we create the database, we create also a table. If we want to enter a name of someone in this database, what data type can we use? Is it number, character, or what? Basically, we can't use number because number doesn't match the name. Okay? If we want to specify the price of a commodity that we want to enter in this database, we have to use a number as a data type. We can't use character. We really can't. So, what is the data type that we are going to use? Okay? Structure. Okay. How is it going to be? Constraint. What rules are going to apply to this? Constraints are just rules. We'll talk about that at a later stage. Of the data to be stored in the database. So that is what it means to define. You just basically specify the data type, the rules, and so on and so forth. Then constructing. Constructing is basically building now. Okay, you want to build this database where you are going to store that data. So that is another functionality. Manipulating. Manipulating is basically changing. Is it checking? Is it getting data? Is it putting another data? And so on and so forth. That is manipulating the database. Functions such as querying, we are going to look at what querying is, but what we are just saying is basically getting or putting data in there or changing the already existing data. That is manipulating. Okay? Sharing the database. Okay. What we are just saying is how many, we can set the number of people that are going to be accessing this database. If it's only admin to access this database, if there are two, for example, if one gets sick, this one can come in, so that we reduce the risk of this data to be we reduce the risk of this data to be changed. So that is sharing. We are just restricting how many are going to have an access to this database. Okay. Or how many at a time can we allow to be processed to this database? For example, when you go on WhatsApp, somehow, somewhere, whatever you post on WhatsApp or Facebook is stored in some type of way in the background. So if you want to forward a message, it will even tell you you can only forward up to 5. You can't forward up to 6 people, unless maybe with business WhatsApp, because I don't use that. If that is different, but for us who use just an ordinary WhatsApp, you can only share to 5 people at max. That is sharing. You are controlling how many can be processed at a time. Okay, that is a restriction you are putting. Then protecting. Okay, basically you have to protect this database. There are hackers. There are hackers. There are viruses. Basically malware, malware, and so on and so forth. You have to put a password so that even a physical person, if they come, they must find the type of protection. This database management system allows for that. Maintaining. Okay, so so what we are just saying, we are saying this database doesn't just have to change on a daily basis. It should change, but not suddenly, not so easy. Okay, that's why we're saying maintaining the database system, allowing it to evolve as requirements change over time, sometimes spanning years. It doesn't have to say this year, this month it changes, next month changes, the other month changes, the other month. No, it doesn't change so easily. So these are the 6 functionalities of this software: defining, specify the data type and the rules; constructing, basically building; manipulating, making changes; storing, sharing, basically controlling how many are going to be accessing that; protecting, some form of protection; maintaining, doesn't have to change suddenly. So now you have database, collection of related data; database management system, software that enables you create and maintain the database. This combination is what we are calling database system. This combination is what you are calling database system. Okay, so this is an illustration of a database system. So you have database system as a whole. This whole is the database system. Then you have DBMS, which is the software. Then then you have the database here. This is the database, and this is the database management system. The combination of these. Okay. So what happens is we are going to be using some application, okay, which we are going to talk about. So there is a user here or a programmer. You as a programmer. Then you are going to be interacting with an application. In this case, we are going to use my SQL, which we'll talk about at the later stage. Then, once you open that my SQL, you have you have this software. Okay, this software now will enable this. It will process. Okay, software process those queries. Then software accesses data. So it will process what you are going to be doing here. Then it will go and access data where it is stored. So this is why it is stored. Now once it accesses the data, it gets that data back. It gets that data back. Then you have it back. We are going to talk about metadata in just a moment. Are we good? Are we good up to this point? Are we good? Question? Give me a thumbs up. Are we good? Hello? Are we good? Do I have people in the meeting? Kindly give me a thumbs up. Are you guys in the meeting? Are you guys in the meeting? Are you guys in the meeting? Okay, Erica is in the meeting. Thank you. Lisi. So the network is now okay, Erica? Thank you. Just now. Okay. Thank you for that. Okay, so these are some of the things that we are going to be talking about. Example of a student database. We are going to be doing exactly this. Okay, so we are going to have a name of a database, the columns like that, then we put in data. For example, the name is Smith, the name is Brown, student number 17, student number 8. Like in the case of University Zambia is 2020, 2021, 2022, 2023. Then you are going to have numbers class 1, class 2. Basically, this is America way. Okay, this is American way. But in with us, the class, maybe the class of 2026, the class of 2027, and so on and so forth. What is your major? Computer science, computer science. We can have a course as the name of a database, then you have those columns, then the data there. Don't worry, we are going to look at this from the practical point of view. Okay, please don't worry much. about what all these mean. The grade report, we can do this as well, and we will. Prerequisites, basically prerequisites are what must be done before you proceed to other doings. Okay, basically that. Okay, so we've looked at defining database. Basically just to specify the data type, the structure, and the rules. That's what we're basically saying. We look at constructing, is just building this database. Basically now this is the stage of building that database to store data. We looked at manipulating, is basically updating, getting, putting, and so on and so forth. Don't worry about this. Basically, they are just here as an example. Dr. Zipani will talk about okay, so Dr. Zipani will talk about this from theory point of view, but we don't want to talk about this from theoretical point of view. We want to talk about this from practical point of view. Okay, I'm going to ask all of you at a certain stage. All of you needs to have my SQL so that you begin doing that. It's a skill on its own. Right, and so on and so forth. So there are characteristics of database approach. Okay, characteristics of database approach. Okay, so basically what we're saying, database approach versus order approach. So what we're just saying here is we're trying to differentiate the database from the files. That's basically what this mean. The whole this. Okay, so we are just trying to differentiate the now and the then. Okay, so characteristics of database approach. We're just trying to compare. Remember, from the very beginning, we have given the introduction, like the background. What prompted these people to build the database? What prompted these people to build the database is basically they are basically the very reasons that we gave at first. When you have when you have an office, then you get the stationery. Today you write the orders, tomorrow you write the invoice, the other day. By the end of 30 days, okay, by the end of 30 days, you are going to have, you started with no file. By the end of 30 days, a file will be full. And you pack it in the shelf. You open another file, you pack it in the shelf. You open another file, you pack it in the shelf. You open another file, you pack it in the shelf. So you'd find that the space keeps on reducing, because while you put a file, you can't put another file. You have to find another space. And again, it makes it difficult. Like nowadays, there are even cards for clinics and hospitals. But back then, when our parents took us to the clinics and the hospitals, we had cards. And those cards, we gave them to someone. That someone started going through the books, Sometimes the book is there, but they will tell you, your book is missing, just get another one. You see? So what we are just saying is, what advantages do we have in using the database compared to file? That is basically what we're just saying here. So a database approach versus order approach. This order approach is basically a customized. I think we've heard of this term, customization. No, custom made. And first, let me throw this question back to you guys. Customization or custom made? What comes in your mind when you hear no, customize it? Msonda, Lisi, please go ahead. Oh, you guys crashed. Anyone can go ahead. Can go ahead now. Okay, Msonda, go ahead. Oh, okay, it's fine. You can go ahead. Yes. Good. Basically, that's it. Okay. Custom made. Um, you can buy a shirt and say, I want you guys to put my image here or a name. That is basically what it is. Good. So the order approach of customizing programs to access data stored in a file. So these characteristics of database approach versus file processing approach are the following. Nowadays, the database is self-describing nature. What do we mean by self-describing nature? I wish this was in the practical point of view. We don't need, basically, let's say in the files, if we have 10 Johns, we need to have a mark to differentiate John 1 from John 2, from John 3, from John 4, up to John 10. Okay? But nowadays, what we are just saying is, all of them can be John Walia, John Walia, John Walia, John Walia, John Walia, John Walia, or Banda Piri, 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 maybe 5 Banda Piris. So with a database of nowadays, we do not have to say Banda Piri, Banda Piri. A good example, when you go on Facebook and you want to friend request CAS, you don't have to know the full username of CAS. Basically, you just know that, okay, this is his name and this is how he's known. But how do I identify the correct CAS? Basically, you just type in KAS and you have a lot of names. What is going to happen? Those names are going to have images. So you would be like, yeah, this is the person I'm looking for. Then you go to that image based on 3 letters. So those 3 letters will give you all the details about this person. That is what we are calling self-describing. Okay? But back then in files, when there is Banda John, Banda John, Banda John, Banda John, you have to go through Banda John, Banda John, Banda John. Village, Isoka, Isoka, Isoka. Date of birth, 1980, 1980, 1980. Very possible. Having same village, same name, same date of birth, same years. How are you going to differentiate these people? And they are all males. So you need to have just specific details of these Banda John that you are going to use to differentiate one Banda John from another. But nowadays you don't have to worry about that. Basically, you can get all the data from this database. If you don't know the specific person, then because there are images attached to that, makes it easy. You're going to say, this is the image I'm looking for. I know the names are the same, but these are images I'm looking for. You go there, you find out more. Yes, this is the person. Insulation. Okay. What we are basically saying, what is insulation? Look at this. Let's get back here. Let's get back here. Look at where the user is and where the data is kept. So basically, you user, it becomes very difficult because you have to interact with a certain application. Then that certain application must be processed by the software, and that software is the one that is going to get data. So you as a user, you can't do this directly without the help of this software and of course application. So data is far away from you. Okay, that is what we are calling insulation. I think you can testify this. You have a wire. This wire is a copper wire connected to electricity. Just your extension cable connected to your electricity. You can hold this extension cable from outside without being electrocuted, without anything being done to you, because there is that protection. So even in this circumstance, what we are basically saying is there is that protection. Data is abstracted from you. Support multiple views. The good example is Wunza SIS. Your details in that Wunza SIS, when you say SIS, you can print the results, you can register for courses, you can do what, and how many students are printing the results at the same time? A lot. So it supports multiple views. Sharing. Okay. Basically, we've talked about what sharing is. Sharing is basically allowing how many people needs to be processed at a time. So that is what we are saying. Self-describing nature. That is today's database. We have this is just a continuation. Insulation, basically traditional file approach. When you make change to one file, you need to make changes to every other file where those information are appearing. That is traditional way. But nowadays, what we are saying is just change to one, updated everything else. Okay, so there is data independence. In this, there is what we are calling data dependence. Why? We gave a specific example. When you go in schools, your name is in accounts office, your name is in deputy's office, your name is in head's office, your name is in mathematics department. So when the data is, when your details are updated in head's office, they need to be updated in deputy's office. They need to be updated in accounts office. If they are not updated in mathematics department, they are going to chase you that you have not paid. Let's say you've paid school fees in accounts, but those details are not in the deputy's office. You're going to be chased. Okay? So that inconsistency, look at that inconsistency now. So there's data dependence. So the update in one detail requires updating in every other field where that data is appearing. But here in database approach, just an update, basically what makes it that's possible is because of DBMS, database management system. Okay, it's going to process, it's going to do that, it's going to do whatsoever. That's what we are saying. Insulation, we've talked about that. Basically, you can't easily manipulate data here. You can't. Not that easy. So this is a stored database. Then the user is basically just outside there. So if there is manipulation in the data in the database, they are going to question you. How you are the person in charge of this? How has this come in? You have to really explain that. Very important. Okay. That's insulation. Basically in here there is no insulation. So change to a structure of a file may require change to all programs that accesses that file. This is just a continuation, insulation, and so on and so forth. Okay, give me a thumbs up. Are we good? Any question? Otherwise, give me a thumbs up. Msonda is okay. Lisi, are we good? Okay, good. Thank you. Okay, insulation between programs and data abstraction. I think we've talked about that. Don't worry about these tables. Dr. Zipan will talk about this in theory point of view, but in as much as these tables were put here, it's not the right time to talk about these tables. It's not the right time. I respect the fact that he's a lecturer, yes. I just regret leaving a book in which I prepared notes. Otherwise, it is not the right time to talk about these tables. So for now, we just look at theory so that we have this understanding. Okay, data model basically is just a type of data abstraction, and data abstraction, I want to take you back. And data abstraction is basically the insulation. Where is that? Here. Okay, insulation. So there is that protection. I gave an example of your extension cable. I gave an example of your charger. You can touch your charger without being electrocuted because that charger is protected. So abstraction is basically the other way of saying protection. Very important. Data model is just a type of data abstraction that is used for conceptual representation. Don't worry, we are going to look at what conceptual representation is at a later stage. Support multiple views. I think we've talked about this. We're just saying how many people can be processed at a go, and so on and so forth. It's not the time to talk about this. Sharing data and multi-user transaction processing. Basically, what we're just saying here is, in today's world, okay, more than 2 people can be looking at the same data at a go. You guys are going to learn about if you go maybe if you go information and security way, you are going to look at how this is. Basically, what we are saying is, you have an account in Lusaka, a bank account. You go to Copperbelt, you can still deposit this money, you can withdraw this money, basically in those lines. So sharing data and multi-user transaction processing. What we're just saying is, there's an ATM here, there's an ATM there, there's an ATM there, 4 or 5, depending on how many ATMs are there, 4 or 5 people can retrieve or can get their money, can deposit their money at a go. That is very, very, very key. Okay. One of the things that you have to know is what we are calling a transaction. I think this is a must know. Let me put it on red. So a transaction is an executing program or process that include one or more database accesses, such as reading or updating database record. In simple terms, let's look at these 2 terms. Reading is just a digital way or a computer way of saying checking. Updating is just a computer way of saying make changes. Okay, so you can just check or make changes to database. So a transaction is just a program that is running. Let's say you want to check, let's say you say, there's an assignment, for example, posted on the Moodle. You go on the Moodle to just check for that assignment. You don't want to start answering that assignment. You are just checking what is it about. That is what we are calling reading. But if you can make changes to that assignment, you observe there is a mistake here. Instead of writing this, they meant this. Then you correct that word. That is what we are calling updating. Another term they will use for updating is writing. Read, write. Read, checking. Write, make changes. So each transaction is supposed to execute without interference from other transactions. And we are going to look at the term that describe this. So when you are reading, what we are saying is, when you are reading, okay, so if reading is running, writing must never run. If writing is running, reading must never run. So you can't check and make change at the same time. It's either you're making changes or you are just checking. That's what we are saying. Same in the process of preparing food. It's either you are cooking or you are eating. You can't cook and eat at the same time. That's not possible. One of the people that you need to know about is the database users or actors. Okay. So one of them is an administrator. An administrator is just basically a chief administrator who are responsible for, number one, monitoring the users. Okay? Acquiring software and hardware as needed. If there's a problem, if Moodle is down, who are responsible or who are people tasked with ensuring Moodle is up? Those are administrators. They'll give you an access. Let's give an example. Each time you want to join the meeting, you can't just log in. I have to give you an access. So in the database terms, I'm an administrator. Then there are designers. These are just people that interact with people, with other people, to collect the information. Remember, you need to have a source of information. You need to have a plan for which you want this database for. Okay? So designers go now out there. There are a number of times, let's say someone graduated some time back, they will come at school and say, I'm working on this. I want you guys to fill in this form. I'm sending a link. Please help. What I want is getting the information from you. Okay? In that case, I am a designer because I'm interacting you either face to face or online. But in some way, I'm interacting with you. I'm getting the details from you about what I want. Okay. Do you think, I just ask you a question, do you think this could be a good idea? And you'll be like, yeah, it's a very good idea. Okay, so how would we go about it? Oh, I feel, since you've said it like this, when it is like this, okay, I'm getting these details from you, writing them down and the like. Okay, so that at the end of it, oh, when I come up with that application, it is going to satisfy you as a user. Remember, database need to be planned. Why are you collecting this information? What is the target audience? How is it going to work? So you as a user must be satisfied. That is the reason I come to you, ask you questions personally. Those are designers. So discuss with all prospective database users in order to understand their requirements, and then create a design that meets the requirement of those users. They are responsible for identifying data to be stored in the database. Not every data that they are going to collect from people is going to be useful. They will say, this and this and this and this, he just talks about this. So we remove this, we go with this. So they are responsible to identify data that is going to be stored in that database and choose the appropriate structure to represent and store this data. Very important. Then there are end users, people like you and I. Okay, who are end users? That's the reason okay. There are types of end users. I should be able to call home. I should be able to call home. I just I just hope we get. It's not possible. Just know that we are not getting back on campus now. There will be possible extension. And if you are that type of a person who would say, no, I have to prepare for exam, then you neglect these other these other courses and the like, please, it is high time you begin little by little working on semester 2. It is very much possible to write these exams at the same time. You are not writing exam now. You are not. There will be a possible extension. Weeks are still very fun. Okay, I will go home for this. Okay, I will go home for this. There are types of end users. Some of the end users, we are going to talk about them right here. Then system analysts and application programmers. Basically, system analysts are software developers. So if you are going to go software way, you become the system analyst. Application programmers are just engineers, in short. So system analysts determine the requirements of end users. Application programmers now implement. These now puts in place what was determined here. That's why you are calling a software engineer. Why you called software engineer? Because on the other end you are a programmer. Okay, so on the other end you are a programmer. So this programmer gives you that engineer. Then you are a developer. It gives you software. Okay, advantages of using the software, which is DBMS, redundancy. Basically, what we're just saying is controlling redundancy. It doesn't stop redundancy. It just reduces. Redundancy means keeping the same information in different locations. That is redundancy. Same. Good example that we're using of school. Deputy office, head office, accounts office, math department, English department, science department. All these offices have your details. That is the redundancy. Now, the database management system reduces that. Okay, so this is data redundancy. Store the same data multiple times. In other words, so redundancy leads to the following problems. Redundancy, that is storing data redundancy. Data redundancy is storing the same data in multiple times. That is data redundancy. And this data redundancy leads to the following and many more, which we have talked about already. And many more. Number one, wasted effort, because there is need to perform the single logical update multiple times. So like we were saying, you pay in accounts office. Those details must be updated in the deputies. It must be updated in the heads. Must updated in math. Must updated. So you are doing that lots of times. Now imagine the deputy is not around. The head is not around. Okay? So you have to put in effort. They will tell you, come back tomorrow. Or come back after tomorrow, the head is not around. Come back that day, the deputy is not around. So it leads to wasted efforts. Wasted storage. Okay, because you are storing the same data repeatedly. You put this file here, this file here, this file here, this file here, this file here. You are taking up space. Data inconsistency. If I tell you update data in accounts, then you are not you haven't updated that data in the heads. That is data mismatch. That is inconsistency. And many more. So in database approach, we have database design that is to each logical data items in only one place. That the approach of storing items, the approach of storing items in one place, this approach is what we are calling data normalization. Data normalization. Advantage number 2, restricting authorized access. Okay. Okay, data inconsistency. The good example that we used is a school. You've been to secondary school. So when you pay fees in accounts office, the update that you've paid, those records must be updated even in the head's office, not so? Good. So if not updated in the head's office, don't you think there's a mismatch there? Good. So that mismatch, when one record is updated, then the other record, there are 10 records of you. 9 updated, 1 not updated. That mismatch is what we are calling data inconsistency. Is that good? Good. Restricting authorization, basically what we are saying is anyone that is, unless I hack your account, unless I know the password to your account, each student has their own account. Okay. Providing persistence. Okay, persistence for storage. What we are saying is, even when, not even if, even when the computer crashes, believe me, you have somewhat a way of retrieving this data. Yes. Database managed system. Yes. The second one was restriction. What we're just saying, only authorized users accesses that data. In Unzasis, for example, can I access your account? Is that easy? No. Exactly. Then, persistency. When your computer crashes, there is a way in which you can retrieve that data. There are so many ways. For example, when you're using a computer, you can use GitHub. When you're using a computer, or you're using a phone, there are Google Clouds, iClouds. There are also flash drives. So whatever you do, you save it on a flash. You can even get your hard drive, your solid state drive. You just remove your hard drive from there and put in another computer, and that data comes back. That's what we're calling data consistency. So data persistence. Okay, so it provides persistent storage for program data. So even when there's a crash, possibilities there for that data to be retrieved. Unlike in file system. In file system, file che because of ink ikaenda mumanzi. Ink is soluble in water. Then word yachokapo or sentence yachokapo. Can you retrieve that sentence? Can you retrieve that sentence? No. Exactly. That's what we are saying. Data persistence. Basically, you just read around there. But what the main message you have to take in is data persistence is basically the possibility of retrieving or getting back data when lost. All this is what it is about. Providing storage structure and search, basically what we are basically saying, we are going to look at this from practical point of view. Let's say you open your let's give this from the point of File Explorer. We've all used the File Explorer, not so? Have we? Okay, Facebook. We've all used Facebook. What we are saying is, instead of going through searching for data one by one, you just type John. And the advantage of using database management system is because there are techniques for searching for data. That's what this whole sentence is about. There are techniques. Okay, you guys are not are familiar with what we are calling the index. Okay, so let's say A at 0 gets you the first person, A at 10 gets you the 9th person, and so on and so forth. Buffering or caching, you guys are familiar with these terms. Okay, so instead of going to the actual storage, this data is at least in the middle stored, so it makes it very, very fast to get that data. Okay, that's what we are saying there. So there is a speed in terms of getting that data because data is cached or data is buffered. Okay, provides the backup. I think we've explained this. What is the backup? You can use Google Cloud. You guys can even create what we are calling what's this? Flash drive. You can also come up with just some type of link where you can be keeping this. So this provides the backup. Provide multiple user interface. What we are saying is there are a lot of ways. There are a lot of ways that you can access this data. Should be in the app using mobile phone. Casual users. This is the type of user we'll talk about this at a later stage. There are programmers. You can use APIs. You can use some type of command or form. Okay. For parametric users, we'll talk about what parametric users at a later stage. The menu-driven interface and so on and so forth. So providing multiple user interface is just a way of interacting. So you can interacting with this database through the app, okay, through the form, and so on and so forth. Representing complex relationship among data. So if I can give you this, let's get back here. Let's get back here. Okay, so this is what is happening in the background. There is a user here. You don't have to learn to know the complexity of what is happening in the background, because this is complex. Imagine you interact with an application, then you write a command for processing, then you write a command for accessing, then you get here. What the database management system does a processing for you, does the access for you. That's what this is saying. Should be 7th. Where is 7th? So representing complex relationship among the user. So there is this complex relationship happening, which makes it easy for you. So database management system represents that complex relationship. Okay. Enforcing integrity, we are going to talk about integrity at a later stage. But basically what we are saying, just put in rules. Okay, we'll talk about integrity and constraints at a later stage. Basic data type, referential integrity. It's not the right time to talk about this. We'll talk about this at a later stage. Permitting inferencing and actions at a later stage. Don't worry about that. So we're going to talk about triggers. Don't worry about what these are. Other advantages: potential for enforcing standards, reducing application development time, flexibility, and so on and so forth. You can just read these for your own good. Otherwise, no one will examine you on this. It's just the extra information. History. You need to know about history. Okay. I prepared very good notes about history. I don't know why. I will go home basically, so that they capture for me. So history of database application. There is early database system, relational database, object-oriented database, web e-commerce, specialized, big data, no SQL. No SQL means not only SQL. 21st century. We are in 21st century, and this is what we're looking at: big data, and so on and so forth. So you can just read around the history. Basically just have to know. Okay, there is early one. Okay, there is early system there. You have to some type of way. Basically, they will never examine you on this, but it's possible they can bring a test. It's one of those questions we had a test on. Okay, I think we have come to the conclusion of this. Unless you guys have a question, otherwise give me a thumbs up. You have a question? Okay, Liz doesn't. So on that, you have a question? Otherwise, give me a thumbs up. Okay. Right, we've come to an end of this, and see you next time. It's good that we've made it up. We're going to look at maybe first 2 or 3 meetings. We'll just deal with theory. First 2 or 3. Then, if first two, then the third will look at the practical aspect. If the first three, then the fourth will look at the practical aspect. Otherwise, thank you very much and have a good wonderful day. Good. I have to upload this before sharing. Good day.